And then our last question for the day is a systems of equation problem. So let me just draw this out first. So it says a systems of equation is shown below. What is the value of x in the solution of the equation here? So I have here, this is y equals 2x plus 3. And I have y equals negative 4x plus 21 here. So again, it's asking us what is the value of x in the solution of the system, right? So in order for us to solve for a system of equations, what we have to do is we can either do substitution or elimination for us to get rid of a variable. Right now we have x and y, right? We have x and y in both of our solutions here, and we want to get rid of one variable here for us to solve for an x value here. So in order for us to do that, again, I would actually get rid of y here because I already have everything's already algebraically done for me. So I would simply just use substitution here. So I have 1 and 2 here. I'm basically going to say that I'm going to say sub 1 into equation 2. So in order for me to do that, once I sub equation 1 to equation 2, I would basically get 2x plus 3 here, and this would equal negative 4x plus 21. Plus 21. I'm equating the y values, which means my y values cancel out. Therefore, I only get one variable here, and we can easily solve for a one variable equation through this value because we're solving for x here, right? So again, what I can do is I can add 4x to both sides. So I've got 2 plus 4 here is 6x plus 3 equals 21, and then I can move 3 to this side, so I'm subtracting 3 from both sides here. 21 minus 3 is 18, and then I can simply divide both sides by 6 here to get me a value of 3, right? I can divide both sides here. 6x divided by 6 here is simply just x. 18 divided by 6 here is 3. So x here equals 3 will be my solution here. If I were to extend this problem and say, can I find the point of intersection between these two lines here, I would simply just have to sub 3 back into this equation here. So let me just do this problem here. So I have x equals 3, which is basically the solution here, and the solution is great here, so that's fine. But if I were to extend this problem and say, what is the point of intersection between these 2 points here, I would have to figure out a y value, right? So right now I have 3 and y, right? And what I have to do is I have to plug in this point into any of these equations here. So I'm going to say maybe equation 1 here. So I'm going to do this in red here and say I have y equals 2x plus 3. And I can simply just sub in 3 for my x value to figure out my y, right? So y here would equal 2 times x here equals 3 plus 3 here. Y would equal 2 times 3 here is 6 plus 3, and the y would equal 9. So which means the point of intersection, so the POI of these two systems of equations here are 3 and 9 here, right? And what we can do is we can actually graphically check this out. So let me just do that for you real quick, and we will end the video there. When we talk about systems of equations, we are solving for point of intersection. So this here is 2x plus 3. Again, we have a linear line like so, and we have negative 4x plus 21. And as you can see here, this point, the point of intersection when we're solving for this will be point 3 and 9 here. The exact point is 3 and 9 here, and this here is my solution, right? The point of intersection is 3 and 9 here. The question is also only asking us what is the value of x. And again, what the value of x of the solution is simply 3 here, right? And that's what we solve for in this equation here. We simply use the substitutions to solve x equals 3 here. However, what we can do is, again, we can extend this problem and say we're solving for our y value as well. We simply just plug in x value into one of these equations, either 1 or 2. Both of them will give us the exact same answer, and then will give us y here equals 9. Therefore, our point of intersection is simply just x comma y, so it's 3 and 9 here. And as shown graphically, if you were to graph out 2x plus 3 and negative 4x plus 21, you would get 3 and 9. And this is the point of intersection in which the two linear equations intersect at. So we solve for this systems of equations here. So the point here is 3 and 9. So let's look at the solution here, and we'll end the video here. Again, what they're doing is they're doing elimination. So they're subtracting the y here. So they're canceling the y to just solve for our x values here. They have 2x minus 4x, which is 6x. And then 3 minus 21 here is negative 18. And then they simply just divided both sides by 6 here, and they got x equals 3. So this solution here is correct. Solution is correct. Can also use substitution to solve for systems of equations, but elimination works as well. Can also extend problem to solve for point of intersection for the two linear equations, and this would be 3 and 9 here. That's the point of intersection here. So POI would equal 3, 9 here. So this here solution here is correct, and this will end my video for today. We'll end a bit early, as I said before, but thank you so much for watching for my video here. Again, we've done basically today we did basically 11 questions, because again the 2 are repeats as well, so I'm sorry for that. Thank you so much for watching the stream. Again, I'm streaming. My name is Joey again. I'm streaming from basically Monday. I'm streaming from Monday to Friday. Monday and Wednesdays and Fridays are going to be math problems, and Tuesdays and Thursdays will be my chemistry problems as well. And I'm streaming 5 days a week, so feel free to tune in as well. Again, thank you so much for watching. As always, stay safe, stay healthy, and have a